Hello, this is Aaron Lewis from Franklin Maths. This lesson is on hypothesis testing with a normal distribution. This is one of the final parts of the course on the statistics side. This lesson builds on previous knowledge that you should already gathered by looking at the distribution of the sample mean, and also some of the skills that we used in the first year with the binomial distribution, and particularly with hypothesis testing on that. Now this video is quite long because of the amount of skills in it. So what I've done is, if you pause it at the relevant sections that I say, do the questions, mark the questions, and then move forward with me. Okay, thank you. So the first part of the lesson is just setting up the hypothesis test, which is fairly easy in itself. It is very similar to what we did with the binomial in the first year. Okay, so we've got some scores in a national test. Okay, with a mean of 100 and a standard deviation of 5. And a school thinks they perform better than this. So 100 there is the sort of population mean. Okay, so what we're going to do is let x equal test scores. And what we're going to do is define our null and alternate hypothesis. So the null hypothesis in this case is where the mean of the school will be 100. Okay, and the alternate hypothesis is going to be where the mean is, well, if they think they're performing better, so the mean is going to be greater than 100. These steps here are really, really important. They're worth a couple of marks in the exam, and they're dead easy to do. It's just getting to the habit. Whenever I look at a hypothesis test written by my students, I expect to see written in this style to start with. It's easy to mark, easy for the examiner to follow, and it's easy. It's easy to get marks in your exam. Okay, moving forward. The average house price in the UK is thought to be non-distributed. We've got a mean of 233,000, and a town thinks that their house prices are cheaper. And we expect to write down the null and alternate hypothesis. So we're going to let x, in this case, equal house prices, or average house prices, doesn't really matter at this moment in time. So what's h0 going to be? If you want to pause the video and write this down, and then mark with me, it doesn't really matter, you can just follow this bit. So the mean in this case is going to be no change, so it's going to be 233,000. And the alternate hypothesis, so the mean is cheaper, so that's where the mean then is less than 233,000. Okay, and on to the last example. This time we're looking at the amount of children in a family, and notice the change in language this time, that the mean is different, not more, not less, just different. So in this case here, x is going to be equal to number of children h0, no change from the mean, u is still equal to 2.33. Now if we're looking for a change or different or something like that, h1, we're going to say that the mean is not equal to 2.33. And I'll mention this now, and I'll obviously revisit it later. So we've got the normal distribution curve there. Now hopefully a couple of alarm bells are going off here, going hang on here, and this is two-tailed, and you'll be right. So what we'd have to do, remember, split the significance level into 2. Okay, but I'm going to revisit that again later, but it's just worth just looking at now. Okay, so that concludes the first part of the lesson. I say it should be nice and easy to get on with. So I'd like to do just question 1 from exercise 22b. Pause the video, have a go, mark, correct, and then come back to the video. Thank you. Okay, so what we need to be able to do is actually perform a full hypothesis test. This example here is using the critical region, so if you want to pause it, write down the title. I've tried to chunk the lesson for you so you can just master one skill at a time. So here we go. So we've got an athlete here. Obviously, I've padded this out with some bit of a backstory for you. In terms of the population mean, we've got 9.95, standard deviation of 1, and then what we're going to do is I'm going to test an athlete. And they're going to give 3 samples before a race, and the mean comes out as that. As you can see already, the mean is higher. And we're going to test whether there's sufficient evidence to suggest whether the level is above average. Remember, what we do with a hypothesis, we can't say for sure whether this athlete is cheating. We're just going to say there's evidence to suggest it's how far it's away from the mean. Now, the only thing this question is missing is a significance level. So I'm going to put a 1% level on this one. I'm not sure why I haven't put it on, to be honest with you. Doesn't really matter right now. Can add it now. Okay, so 1% level. So what we're going to do is work through it. So here we go. So first thing we're going to do is just as we did in the previous slides. We're going to let X equal the concentration of hemoglobin in the blood. We're going to write down our null hypothesis, which is the H0 there. And H1, because we're looking above the average, is going to be there. Now this little line here, it's worth jotting that in. It's always the same thing. X is normally distributed, and you've got mu, and you've got the variance there. Now we write mu there because we're going to be testing that hypothesis right here. Okay, so that's worth a couple of marks in your exam. Not difficult to do, easy enough to work with. Okay, so this is what we need to be able to write down now. We're going to write down then under H0. Okay, now this time, because we're looking at the athletes' samples, we're going to be using basically the sample mean. So I'm going to be using X bar this time. Normally distributed, and the mean is still going to be 9.95. But what's going to go here? So let's just jot a couple of things down then. So we know that mu is equal to 9.95. And remember, when we're using X bar, I'll just write that, X bar, the standard deviation changes. Okay, so the standard deviation is going to be the square root of sigma squared over n. So 1 over 3 like that. Remember that the variance then is going to be a third. Okay, and remember that's just taking the 1 there and dividing it through by the samples. Okay, so maybe I should have written at the top there n equals 3. If you just finished the video, or within certainly the past week, looked at the video on the distribution of the sample mean, please look at that video beforehand, because that will make sense. If you haven't looked at it before, that might not make as much sense as it should. Okay, so a third needs to go in here. Okay, and I'm going to write this down again, but it doesn't really matter. Mu is 9.95. My standard deviation is going to be the square root of a third, or the square root of 1 over root 3 or root 3 over 3, it doesn't really matter. So what I'm going to do is I'm going to get myself the critical region and then work from there. So there is a picture of the normal distribution curve. We know that the mean there is 9.95, and what we're trying to do is work on the 1% level, which is, now the thing we need to realize here is if we're using left tail or right tail. Well, because we're looking above average, it's going to be over here somewhere. And at the 1% level would mean that area there is 0.01. So you could use a left tail here, could use a right tail, doesn't really matter. This is going to be an inverse problem because we know the area. So I'm going to attempt to find out that number there. So I'm going to pull up the calculator and have a look. Okay, so here's my calculator. I'm going across to stats, distribution, normal, inverse. I'm looking at a right tail, area of 0.01. My sigma is going to be the square root of a third. And my mean was 9.95. So that comes out as 11.29. So that's going to be 11.29. Just put that in there. Okay, so let's have a look then. So at the 1% level, it was 11.29. So we need to ask ourselves the question then, is whereabouts is 11.5? Is it in here, what we call the acceptance region? Remember, that's where we accept H0 in there. Or is it in the rejection region, or what we sometimes call the critical region in here? Well, 11.5 is in there somewhere. Okay, so that is the rejection region then. I'll put a slash in it, or critical region. Okay, so 11.5 is quite far away from the mean. So we've got quite a lot of marks in the exam so far. So how do we finish it off? So the first thing to say then is to say that 11.5 there falls into the rejection region or the critical region. So we're going to reject the null hypothesis. Okay, if you think about it, this is so far away. Well, we must have to reject that. Okay. Now we know on the exam you get, that's certainly worth a mark for stating that. You will get the mark as well just for writing reject H0. For those of you that really don't like writing, I always tend to write it out in English if I can. And then the last mark then is, and it is always the same sentence every single time, same in the binomial, there is evidence to suggest that the athlete's hemoglobin level is above average, which there is. Okay, we can't say for sure whether cheated or not, we just know that there's evidence to suggest it's certainly way above where we'd expect. Okay, so that's using the critical region. I say it's nice and easy to do. There isn't too much to it. It is a lot of writing, but it's worth a lot of marks in your exam. Okay, so what I'd like you guys to do is have a go at question 2 from exercise 22b. There isn't any context in the question, so it's literally just get on with the maths. I prefer to always do them in context, it makes a bit more sense. One thing to watch out for though is if you're using a different or a changing sort of question, you must split the significance level into two. So if it's a 5% level, you'd have 2.5% either side. Okay, and you'd need to do both. Or you could use the symmetry. It doesn't really matter. Just watch out for those. Okay, so pause the video, have a go at question 2, and then press play when you're ready to move forward. Okay, so what we're going to do now is do a slightly different sort of question. This time we're asked to find the critical region rather than do a full-blown hypothesis test on it. So it is quite nice to do. It's not particularly horrible, this. Right, so we've got flow of oil going through a pipe. It's normally distributed. It's got standard deviation. Again, I've padded out with a bit of a backstory for you. So they've had a leak. The pipe's fixed, and we're going to take 10 measurements. And we're going to use a hypothesis test at the 10% level to see whether the mean values, determine the range of values which would result in us accepting that the flow of the rate has changed. Okay, if you get more words out there. Okay, so this time we're going to try and find the critical region. I've chosen one which has changed as well, just to give you that experience as well. Okay, so first thing we're going to do is jot down what we know. So we're going to let x equal the flow rate of oil through the pipe. Again, that line goes in there. We know it's normally distributed with a mean, well, that's what we're tested. Now the standard deviation was 2, so that means that's 4. Don't forget to do that. It's the biggest mistake I see is the variance in the standard deviation. Write it down every single time until you get fed up with it. H0, the mean hasn't changed. And H1 is that the mean has changed. So this is going to go two-tailed. So we're going to try and find the values where we go, hang on a minute, there's been a change. Let's see what's going on. Okay. So we're going to start as before. So first thing we're going to do is we're going to change the distribution ever so slightly. So this is work that we looked at before on the distribution of the sample means. So this is still going to be 20. And the variance in this case is going to be 4 divided by the number of samples. Okay, so I'm going to write down my mean, is equal to 20. My standard deviation in this case is going to be the square root of 4 over 10, because that's what's going to go in my calculator. Okay, so there's my normal distribution curve. Now, because we're looking at the 10% significance level, and we're looking at a change, and also we're looking at a two-tailed test here, we're going to have to split it into two. So there we go. There we go. So that area there is going to be 0.05, so that's 5%. Same with that one there, 0.05. Lots and lots of ways of doing this question. You could use a central tail, inverse a central tail, and say, well, this area here is 0.9. You could use a left tail and a right tail individually. It doesn't really matter. You should end up in the same place. So if you pause the video and have a go yourself and do it a slightly different way to me, don't worry about it. It's absolutely fine. For ease, I'm going to use a central tail because it's just one calculation. So I'm going to find out those upper and lower values there. Okay, so I've got my calculator. I'm going to go to stats, distribution, normal. It's an inverse problem because we know the areas. So in this case, I'm going to be using a central tail. It is easy with these two-tailed tests to do that. The area of the middle is 0.9. My sigma is, I'll jot this in for you, the square root of 4 divided by 10 or 0.4, doesn't really matter. Mu is 20, and there we go. So we've got 18.96 for the lower one. So that's 18.96. And for the other one is 21.04. Okay, and basically then what we're going to do is write down the range of mean values. So for us to reject H0 and say that there's been a change, we'd have to say that X, the distribution of the sample means, is going to have to be less than 18.96, or the distribution of the sample means is going to be greater than 21.04. Okay, so in this case here, I'm just finding out the critical region. It's worth less marks in your exam, but it's not really difficult to do. In some ways, it's actually easier than the previous problem. Okay, so hopefully you're happy with that. Hopefully it makes a bit of sense for you. Again, it does build on everything we've done so far. Okay, what I'd like to do then is get on with question 3 from exercise 22b. It should be fairly easy to get along with. Just watch out that they've used a small x instead of a capital X. Don't worry too much about that. There's no context in the questions either. Feel free to set up a table if you want for that. So it should be fairly nice and easy to get along with. And after that, we'll look at some more. So pause the video, have a go, mark, check, and then press play again. Okay, this little section is hypothesis testing, but this time I'm going to be using p-values. Now, if I was your teacher for the binomial hypothesis testing, you'll know that p-values is my preferred method, and it always is my preferred method because it is easier to do, but you do need to know the other techniques as well. Certainly being able to find the critical region, which you was definitely taught for the binomial as well. So this is my preferred method. It's normally quicker and a little bit nicer to use. So we've got a newspaper article claims that people who live in the town of Little Snoring are unusually clever. We're going to investigate it. Got a sample size of 64. Give them an IQ test. I'm going to work on this as before. Okay. Yeah, I did a little bit of fun of finding interesting town names in the UK. Most of them were inappropriate, but Little Snoring was fitted quite nicely. Okay, so we're going to get on with this. So I'm going to let X be the IQ of the people. Again, I've just shortened that down because I don't want to waste your time too much. That line again goes in. Okay, and remember I've written that as 20 squared there, doesn't really matter. In this case, the null hypothesis is where the mean hasn't changed from 100, and the alternate hypothesis is where we're saying that should be 100 there. Let me just scribble that out. It's where the mean is greater than 100. My apologies for that. Okay, and we're going to approach this in the same way as before. So we're going to say that X bar n, so this is the distribution of the sample means. We know that mu doesn't change, but the variance is going to be 20 squared divided by the number of samples divided by 64. And remember what that does, that scales that normal distribution. Okay, so fall into good habits here. Mu is going to be equal to 100, and my standard deviation is going to be the square root of that, which is just going to be 20 over 8 in this case. Okay, you can just square root in calculator, it doesn't really matter. Okay, so what we're going to do is we're going to test p-values. So we found that the mean here was 105.6. So we're going to try and find out basically what the p-value was, what the probability. So what we're going to try and calculate, now we haven't done this for a while because we've been doing lots of the other bits and pieces. We do need to revisit. So we're trying to find the probability that the sample means was greater than or equal to 105.6. Okay. Let me just show you on here what I'm talking about. So there's 100. And we actually know this bottom value here. We know that 105.6. And what we'd like to do is calculate that probability there. So it's not an inverse problem this time. It is always worth recognizing whether it's inverse or not. Just change this from looking like 6s. There we go. Okay, so I'm going to grab the calculator, do this as before, and get on with it. Okay, so here's the calculator. In stats mode, just exit out of that a second. Distribution, normal, NCD, because it's cumulative. So our lower value is 105.6. This is a really good revision for everything we've covered so far. The upper value, again, just choose a really large number or something at least 3 standard deviations away from the mean. I'm just going to choose 1,000,000. My standard deviation is going to be 20 divided by 8. So 20, I'm just using the fraction button this time, over 8. And mu is 100. So the probability of that is 0.0, I'll take that as 125. So the area of that there is 0.0125, and let's convert that into a percentage then. So that is 1.25%. Okay, so the next thing to do then is just like we did with the binomial stuff, you just compare these two. So let me just jot that down there, 0.10, sorry, 0.0125. So 1.25%, let's have a look. We're using a 1% level here. Can you remember from what we did last year? Can you remember what the statement was going to be? Let me put a bit of context in it. So if it had been at 1% or lower, we would have rejected H0, because if you think about it, the further you get away from the mean, the lower this probability goes. Okay, so if we're looking at a 1.25% and the 1% was the sort of the critical region of the cutoff here, this actually lies in the acceptance region. We could actually do this backwards and work it all out. So in this case here, we're going to actually accept H0, okay, because this is it's not far away enough from the mean for us to go, hang on, there's difference. Obviously, that is a very, very small amount. It's just at the 1% level, it's just not enough for us, okay? And there isn't evidence to support the claim that the people are unusually clever, okay? So that's just comparing. That's just using the p-values. I prefer to use p-values. They are quicker. It'd be my preferred method unless I was forced into asking, being asked the critical region, things like that. Okay. So what I'd like to do is sort of combine everything we've done already. So that's questions 4 to questions 8. They do get more difficult as you go down. Just pay close attention to all little bits and pieces that I've mentioned. Good luck. I've only got one more example after this, and that's where I have to bring in the standard normal distribution, and after that it is finished. So pause the video, have a go at that section. It'll probably take you around half an hour to an hour. Mark, correct, etc. And then come back and watch the rest of the video. Okay, so this final example is using Z values. On the old syllabus, you had to use Z values. You were given a table, you had to read from it, so you had to convert everything to Z values before you perform the test. So it was slightly more difficult to work with, but certainly not impossible. So again, I've put all this in context for you, and then we'll work from there. Okay, so using Z values. I've got a manufacturer of some breakfast cereal, normally distributed, got standard deviation there. They've had reports that people contain less than they should. I'm not really sure how that would happen. People sat there weighing it. I don't really know. However, we've got a consumer group here who have chosen 200 random packets, and they're going to calculate the Z statistic. Now, the reason they're doing this is because they don't have one of these fancy calculators, or they didn't do the A-level maths that we're doing. It doesn't really matter. So what they're going to do is they're going to try and find the critical region, and they're going to work on the 5% significance level. Okay, so we're going to try and find out what's underweight or not. Okay, so if you want to pause the video, jot everything down, leave several lines between A, B, C, and D. I'm going to do this over several slides. Again, this is quite easy to work with. It's not horrendous. It's just when students are faced with something that looks slightly different, they freeze and can't get on with the question. Okay, so don't worry about that. I'll guide you through it. Okay. Okay, so question back up. So first thing I'm going to do is write down the null and alternate hypothesis. So first thing I'm going to do actually is define what X is. So X for me is just going to be it should be mass rather than weight, but don't worry about it. I just call it weight of, I'm going to just call it cereal rather than honey pops every time. So the null hypothesis in this case, H0, is that the mean is what they told it was. Told us it was 500 grams. And the alternate hypothesis, have a look at the question, can we find out anywhere where it mentions more or less? Well, they think that they contain less. So we're going to be testing whether that mean is less than 500 or not. Okay, now this one here, this does look like an exam question. Most students, I think, would be quite happy with all the previous slides, and then meet something like this and go, oh, hang on a minute, I'm not comfortable using Z. Don't worry about it, we'll be able to do this. So, the distribution Z. Now remember, Z was reserved for a special type of distribution, the standard normal distribution. So Z tilde N, it's always 0 and 1. Okay, I'm not going to sketch it because I'm terrible at sketching it. Okay, so we know that all normal distributions can be turned into the standard normal distribution. Okay, so that was fairly easy to get on with. These two questions aren't really connected, which sort of does throw students in the exam, because you look at this going, well, hang on a minute, how's it even fit in with this? Typical sort of examiner sort of thing to do, and then the questions afterwards will tie things together. So let's have a look. Okay, so part C and part D. So we're going to try and find the critical region in terms of Z. Okay, and you're thinking, oh my god, what is going on there? So have I put the next bit? No, I haven't. Right, so we're going to sketch it. and we'll have a look. Apologies, I'm not very good at sketch. Just make sure yours is way better than mine. Okay, now we're using the Z, so Z tilde N 0 1. So here's 0. Okay, now the critical region in terms of Z, we just need to look at anything in the question. So they're using the 5% level. Don't worry about that bit of the question there. I've copied it, that's all. So we're trying to find out this here is 0.05. We're going to basically find out the Z score for here. So how many standard deviations below the mean will 0.05 give me? So you maybe already know that's around 95%, something like that. Okay, so grab the calculator. Let's have a look. Okay, so just X from there. So this is dist normal distribution. This is an inverse problem because we know the probability. This is a left tail. We have an area of 0.05. Our sigma in this case was, I've lost it, no evidence, there's 1. You can see it's been a long day already. And my mu in this case is 0. Hit that, so minus 1.645. Minus 1.645. Obviously I made a mistake when I said a minute ago. I was thinking about two-tailed. Okay, so the critical region in terms of Z. So if we get a Z score, so it's not the critical region, it's where Z is less than, or could be equal to, it doesn't really matter with the normal distribution, minus 1.645. So if we get a Z score out of less than that, then we know whether it's in the hypothesis test. Okay, so we're gonna test this one then. Okay, so what we're going to do is we know that X, the distribution of the sample means, is 498.5. Okay, now we're going to try and work out the Z value. So what we're going to do is use this little formula up here. Okay, so let's calculate that. So Z is equal to X bar, so 498.5 minus mu, which was 500. We're going to divide that by sigma. Now I need to find sigma out of the question, which was 5, divided by the square root of n. So that's going to be the square root of 200. So I'm going to bung that through my calculator, see what comes out, and we'll have a look. Okay, and that comes out as minus 4.243. So that's miles away from the mean. Okay, so what we can say then is that as minus 4.243 is less than minus 1.645, what we're going to say in this case is that we're going to have to reject H0, and there is evidence to suggest that they are underfilling their packets. Okay, it's worth looking at the problem in terms of you wouldn't expect that, but because we're using 200 packets, the mean shouldn't have been that low. Okay, that concludes this video. There's only 2 questions after that. If you've got everything right and done, and everything's been checked, really well done. And I'll see you all soon. Thank you.